has become 20. So now it works correctly. And then your cost has become really low because that e minus 5 is technically saying 8 times 10 to the negative 5. And that's a really small number. So what this is, so the reason why I'm doing this is because this is pretty much like practice for you to optimize optimize what's it called, the learning rate and the coefficient of friction. So pretty much uh like defining your, so this is defining our model. Like defining our model is one part, but then training the model is another part, because you need to, what's it called, you need to train the model correctly. So it's kind of like a game where you need to figure out these numbers that work. Okay. So let's go back. Okay, so yeah. Let me see. Yeah, okay, so yeah, so this is just a review of like what we end up getting. And if we take a look at our cost over time, like this is the graph. So it goes down, but then it comes back up a little bit, and then it slowly gets to 0. And so cost is error. And then weight, your weight, I'll put them, yeah, I'll put them side by side like this. Okay, so your weight, on the other hand, it increased a lot, but then like it went back down a bit, and then it started hitting 10. And then your bias, it has been increasing like this whole time. It's just increasing. But then this is with momentum, where like you add extra velocity. So your updates are a little bigger. So let me see. If you compare this to what we had uh, before, if you compare the bias that we had before, like you see that over here, it took 10,000 epochs to get to 20 for the bias. But then over here, it only took 600. And that's what happens with momentum, because it's like a simulation of a ball rolling down a hill. Because at the very beginning, the ball like increases its speed very fast, which is what's happening over here. Like it's increasing its value really fast. But then slowly, as you hit the end, like the bottom of the hill, its speed starts to slow down because the coefficient of friction is slowing down the ball, and what's it called, its weight, like its its weight from gravity starts to be smaller and smaller, which is like the derivative getting smaller and smaller as it like, and as it gets to like, as it like gets to the bottom of this hill. So this is like a graphic to understand like why what's it called, why momentum works. So let's say on the first, so you start over here on your cost function, and then your first velocity that you have is gonna be this much. But then because you have a coefficient of friction, what happens is that you, your velocity, your first velocity gets shrunken down to here, but then your derivative at this point, your slope at this point is this long. So that in reality, you update all the way to over here. But then if you weren't using momentum, you would only have this orange arrow. So you would update to somewhere like here. So that gives you a speed boost. And then from all this, from this one, it gets shrunken a little too, and it goes over here. This velocity gets shrunken by half again. So it goes like that. And then the last part is this, which is this is your new derivative at this point. So as you can see, like at the very beginning, its velocity is the biggest. Like at the second velocity, it's the biggest because it's sped up. But then as you get to the end, it slows down because of friction. And then it takes some steps to get to the end. Okay, so that's how momentum works. And then what we need to do next is what we're gonna do, what's it called, next meeting. And this is RMS prop. So this is trying to solve the problem of, let me find it. So what we're doing is, you see how the weight, like it increases way too much, okay? But then the bias, so that means the learning rate for the weight is too big. But then how about the bias? Is the learning rate big enough? I mean, is the learning rate too big or too small for the bias? Yes. So since it's too small, the problem is our learning rate. So our learning rate that you set for 0.0.01 is too small for the bias, but then it's too big for the weight. So what RMS prop does is so we have a global learning rate. So we're gonna call this a global learning rate. And then for the bias, we're gonna have a learning rate for the bias and a learning rate for the weight. So then that the weight, so the for so that the weight for the for the learning rate of the weight, it won't be too big anymore. It'll just update normally like the bias. But then for the bias, it will be a little bigger so that it increases faster. So since this meeting isn't over, I'll start giving an intro to RMS prop. So let's say, okay, so let's say you know how, okay, what's the change here? Oh, that's barely a change. What? Oh, okay, I messed up there, I guess. Oh, that's weird. Okay, whatever. So yeah, so let's just do an intro to RMS prop. So contour, was it contour? Yeah. Okay, so yeah, I'll get through the contour. Okay, so for RMS prop, let's say that since you want the bias to increase faster, you give it a less coefficient of friction. Because if you look at the bias, you look, oh shoot, that's a giveaway. Momentum bias. Okay, if you look at the bias, like it starts slowing down its speed really fast. Like in the, like somewhere around here, it starts to slow down its speed. And technically, you shouldn't start slowing down over here yet. You should still keep on going. So what you can do is have a bigger coefficient of friction, but then we're gonna set the learning rate to 0.001 because if the weight, because for the weight, the learning rate, I mean this is gonna be very bad for the weights if we stick with 0.01. Okay, so we're gonna stick with 0.001, and then you're gonna see that it gets there in 200 epochs, so only 200 updates. But there's a problem with with how we're updating, and that's what we need to fix. So if okay, so what happens is that in 200 epochs, which is 200 updates to the weights and the biases, our weight is technically 10, but our bias is really close to 20. It's pretty much there. And then your cost is like 0.5 now. So if you look at the history of how we update, so look, if you look at the cost, this is bad. Like you start lowering your error, which is your cost, and then you increase it again, but then you decrease, increase, decrease, increase, decrease. And we don't want that. We want it to like consistently fall down. We just consistently fall, not like fall and then come back up. Like you don't want your error to come back up. Like that doesn't make any sense. And then the reason for why it's coming back up is because if you look at the weight, your weight is, you increase too much at the very beginning. So your weight all the way goes to 20. And then it goes down because it needs to hit this 10. And then it keeps on oscillating around this 10 value. And the reason why it's oscillating is because it's waiting for the bias. Oh, that's a bad. Bias. Okay, so it's waiting for the bias to hit 20, but like the bias is wiggling as well because the weight is wiggling, like it's going up and down, up and down. So like both of these are controlling. So the weight is controlling the movement of the bias, but then the movement of the bias is also controlling the movement of the weight. So that's a problem because we don't want the weight to be like wiggling around here, waiting for the bias to hit 20. And we don't want the bias to be affected by what the weight is doing either. So like there's something what we can do is, so you know how the cost, right? So you know how right now, so what are the parameters we have right now? So what two parameters do we have? William? Oh, the meeting's gonna end in 10 minutes. Yeah, okay, so we have the weight and the bias. So since we have two parameters and we have a cost function, so technically the cost depends on your predictions, but then your predictions depend on the weight and the bias. So then what we need to do is create a 3D graph, a 3D graph of the, a 3D graph where the cost is on the z-axis. Well, like, you know, X, Y, and Z axis, right? You know, 3 dimensions, right? So let's just say the cost. So the cost is going to be the dependent variable. And then the what's it called? The weight and the bias are going to be, oh, okay. So the weight and the bias are going to be independent variables. But then the problem with doing a 3D graph is that we cannot like, it's hard to simulate a 3D graph. So what we can do is create a contour plot. Have you heard of a contour plot? Oh, okay. So let me introduce that to you. So a contour plot is technically, find one contour.